So thank you to the many participants that are signing in. We're going to give everybody just a few more minutes. We're about 3 minutes shy of the hour, so we'll probably give it 4 minutes, and then we'll jump in and get started. Just about a minute away from starting. Thank you for your patience. Just want to make sure people have a chance to come in. May hear some additional beeps shortly. All right, the lobby's starting to fill up now. Again, I apologize. We'll give everybody just a few more minutes so we don't get interrupted by those beeps. So hang tough. We're almost there. Okay, I think we're going to launch into this. We might have one or two stragglers in the next minute or so, but looks like we have filled up the event quite nicely. So good morning, good afternoon, good evening, depending on where you are around the globe. We really thank you for joining this event, which Jason Rouault, Senior Director of Cloud Engineering and Operations, will lead momentarily. It's going to be about dynamic and continuous management control and monitoring of OpenStack security at scale. Please be aware that everything we're going to talk about today is applicable across all cloud environments, from VMware to Azure, AWS, Google Compute. You will see that it is completely applicable across those environments. So if you're not focused specifically on OpenStack but are focused on AWS or Azure, for example, you'll get a tremendous amount out of this, so we hope you'll stay with us. Let me introduce today's leaders. My name is Richard Eisenberg. I'm the VP of Client Development at CloudVisory, but most of this presentation today will be led by Jason Rouault. I'm really thankful, and we are really thankful here at CloudVisory to have Jason with us. He was previously the Director of HP Public Cloud, most recently the Senior Director of Cloud Engineering and Operations at Time Warner Cable. He is well known for his leadership in the cloud, and he has a tremendous amount to offer today. He's going to outline real-world problems around cloud security that he faced and his team faced at Time Warner Cable, and he'll discuss how they attacked and resolved these very major cloud security challenges. So I think you will get a tremendous amount out of this. A small bit of housekeeping in the lower left corner of your screen. You'll see this blue and white icon that says raise hand. If you click that, it will allow you to type questions into the Q&A chat window. And what we're going to try to do is get to as many of those questions as possible towards the end of the session. Everybody will be muted except for the presenters, just to keep things clean and easy. But that's a great way for you to get your participation and your voice heard by just clicking the icon and typing in any question you may have about today's presentation. So we're going to do the following today. I'm going to pass this off to Jason. He's going to do an introduction to Time Warner Cable. He's going to talk about his business and security problems and define that set. Talk about the solution requirements that they were trying to obtain from the market. He'll talk about CloudVisory, a security platform that he ultimately used, and its integration with OpenStack. Then I will take over and do a very short overview of CloudVisory so we can actually get into a demo and show you exactly how Jason and his team solved many of the security problems that they were facing. So really, again, thankful to have Jason here. With that, I'm going to pass control off to Jason and let him take over, and I hope you guys enjoy this.
Great, thank you for that, Richard. So to start with, let me give you a bit of context about Time Warner Cable and its cloud. So for those of you who don't know, Time Warner Cable was the second largest cable provider in the U.S., providing video, broadband, phone, and business services to about 15 million subscribers, including those in Los Angeles and New York markets, and operating all this out of 4 national data centers and 20-plus market data centers. Pretty significant size and of infrastructure. And for those of you who didn't catch it, I stated Time Warner Cable was, and that's because Time Warner Cable was actually acquired in 2016 and is now Charter Communications. I just wanted to throw that out there. But from a cloud perspective, Time Warner Cable, what we did there is we built a significant private cloud with OpenStack supporting many differing workloads. It included all the kind of anticipated base IaaS services you would expect, plus higher order services such as DNS as a service, load balancing as a service, database as a service, and monitoring as a service. It is spread across 2 national data centers with capacity for about 15,000 VMs and offering about 3 petabytes of usable object storage and block storage. And we implemented software-defined networking based upon Neutron ML2 with VXLAN overlay. We did not leverage any particular vendor's OpenStack distribution, but instead assembled a highly talented DevOps team that instituted CI/CD automation for software deployment. Our production environment is 0 to 6 weeks behind trunk, depending upon the particular service that you're talking about. So pretty substantial private cloud supporting a number of critical workloads. So why OpenStack? I think it's just important to draw on this for just a moment here, because it really provided the most flexible and adaptable infrastructure for the private cloud that we were doing. It gave our cloud users a self-service model similar to AWS, and that really increased their speed to market while reducing overall costs for the company and without any vendor lock-in. So it was pretty good. While OpenStack brought strong features around multi-tenancy and that infrastructure abstraction, and it allowed our teams to deploy workloads at speed and reliably in a repeatable manner, it also exposed some problems. And those architecture, these are the problems that we will really want to talk about here over the next few slides. The architecture itself introduces risks that traditional perimeter security models and processes are unable to detect and control. When I say architecture, I mean the cloud architecture in general. So, for example, wide open security group rules were not uncommon to be found in the environment, and that's because new users or non-technical users will typically do this in an effort just to get their applications working because they're running into problems and they don't understand the security group rules and things like that. And then things often get left open and not locked back down. Another example is security concerns within private networks and the way we did VXLAN overlay. There was concerns about horizontal breakouts and how would we be able to detect this, and more importantly, how could we prevent it? The next problem area was really had to do with the dichotomy that was uncovered really between traditional security and DevOps teams. The network and security teams were not integrated into a single kind of cloud DevOps team or team in our environment. So there were separate teams. So it was very much a tug of war of sorts between those teams. And the tug of war was about how much control should you afford the DevOps teams, the teams building the cloud applications pertaining to the networks and connectivity and security rules. And then how much visibility and control should the security team have over those applications and their deployments? And that was always at odds, and it caused a lot of problems. So let's dive in and talk about those problems specifically. So the first area is visibility. The network connectivity in our cloud and in most clouds is very much black box. And that's good in a number of ways, but it also causes problems. It makes it very difficult for DevOps teams to onboard applications and troubleshoot network connectivity issues because they don't understand what is going on and why things are behaving the way they are. And for applications that span regions, leverage maybe a hybrid cloud, or rely on multiple cloud providers, this visibility issue becomes magnified because with infrastructure heterogeneity comes added complexity. Security teams are now reliant on good behavior of DevOps teams to correctly manage their application security controls, and they have no easy way to monitor and validate those controls either. So they're kind of at the same mercy as the DevOps teams are with that black box model. So ideally, what I longed for, and many of our cloud users longed for, was a visual representation of our entire cloud. Wouldn't that be great? Wouldn't it be great if we could see all the providers, the workloads, the security groups, and the data flows? That would just be tremendous. But we didn't have that. The second area, or problem area, has to do with control. Managing security controls, aka security groups, in OpenStack can be complex to the uninitiated, and thus very easy to get wrong. And that can result in broken applications or applications that are left in a vulnerable state. I've seen examples where an application that was meant for internal use only, like a website, was accidentally exposed to the broader internet just because the user didn't understand how to properly whitelist IP ranges. That's not acceptable. Hearing this, some might argue you should just take away the cloud user's ability to manage security groups on their own. But the problem with that is now all of a sudden we've removed a big piece of the self-service capability in our cloud. And then we would likely slow down the velocity and ultimate time to market of our customers. So we didn't want to take away that capability. Ideally, we could have a solution that would afford the self-service the users were accustomed to, but would also provide some mechanisms to keep them from shooting themselves in the foot. That would be nirvana, at least it was at that time. The next area has to do with how the security groups themselves are applied, and they're really applied per VM. And because of that, it doesn't really scale well in large deployments. I mean, it might work for small deployments, but when you start talking about having to manage these security groups, which it can be multiple groups per VM, and it could be multiple or hundreds of rules within a group. And when you start going from 10 VMs to 100 VMs to thousands of VMs, and you look at multiple environments like development, testing, staging, production, and then potentially multiple cloud providers, you get the point. It doesn't scale real well. And this leads to the next issue, that security group rules must be explicitly applied to each VM. Wouldn't it be great if things could be more dynamic? I mean, I would really prefer a model where security policies were applied and updated on workloads based upon a tag or set of tags for that workload. You could think of this as kind of a context-aware kind of security policy application. So when new workloads come online or they scale, the correct security policies would dynamically be applied to that VM based upon its tags or context. And then the last bullet item here is, just ask yourself, who deploys cloud security controls, whether using the native UI or the CLI or the scripting it today? Is it the DevOps teams? Is it the security teams? In our cloud, this differed by application. But what team owned the application, whether the application was for development or test or production, whether or not it was IT facing or subscriber facing. It would really seem like the ability to define kind of security trust zones with owners for managing those security policies was missing. So the next area or business problem area relates to compliance and reporting. So how does one actually demonstrate compliance in a self-service world with DevOps teams? There's no real way to show that security group rules in place match an agreed upon compliance rule set or have not changed over time. I mean, it's just without building all those facilities in place, it's very difficult to do that. And then what about detection and response? If policies are accidentally or maliciously altered, impacting risk or applications, could that be detected, and how long would it take to repair that? Similarly, if malware has compromised a VM today, how long does it take us to identify the issue and remediate back to a compliant state? These are all concerns that we had and didn't know how to deal with in this environment. So we started looking for solutions, and when we did that, we put together a set of requirements beyond solving the problems that I stated earlier, but there were some functional and actually architectural requirements that were important to us. The first one was any solution needed to leverage cloud-native security controls. We didn't want to add in an additional security controller environment. That would just unduly complicate the environment and make it very difficult for us to support and troubleshoot. Next, we must not negate the self-service that our customers were used to. It would be just a no-go if we impeded that at all. Thirdly, there had to be minimal to no impact on the workloads as far as performance. So we have many customer-facing mission-critical applications running in the cloud, and if they suffered any performance degradation, that could result in loss of revenue for the company. So this was very, very important to us. Second to last, our cloud was growing very rapidly, so any solution needed to be able to kind of grow with our cloud and where we envisioned it to be. And then it had to be highly available. It was a mission-critical cloud. Any solution that's part of it needs to be highly available, so that was key. And then just continuing on with some of these requirements, the installation and upgrade of the solution needed to be automatable with our CI/CD tooling. We don't touch anything in production. Everything's automated, and we needed to keep it that way with any other solution that was addressing this particular area. And going along with that, we needed to make sure the solution didn't hinder our ability to upgrade the hypervisor itself or OpenStack. We're doing weekly, sometimes multiple times a week, deploys to production, and that involves deployments to the kernel, the operating system, and OpenStack, and we couldn't have a solution hindering our ability to do those deploys. So that was pretty key. And then role-based access control, we really, like I mentioned earlier, we really needed a way to be able to segment out who could manage and view security policies for workloads and groups of workloads. And of course, the solution needed to offer an API to integrate with existing systems. So with that said, we started looking at solutions in the space, and it became actually pretty easy to narrow down the choices. So some of the solutions out there, they want to just take over your SDN, or they are an SDN themselves, or they want to take it completely over. That wasn't going to work for us. We were happy with leveraging Neutron with VXLAN and OVS, and we wanted to be as close to upstream, and continue being as close to upstream as possible. So we needed to make sure that we weren't forking anything there and that type of thing. Another approach that's often seen out there is vendors like to install a VM on every single hypervisor that does some of the operations of controlling policy and inspecting packets. And while we were open to this, it wasn't a preferred approach. We had some concerns about it would have some impact on potentially overall performance. But mostly we were concerned it would impact the model that we had for how we brought new compute nodes or hypervisors online, how we did maintenance on those nodes, and as well as how we reported out capacity in general. Another way that some of these solutions go about this is they actually want you to install a kernel module, and we definitely wanted to stay away from anything that lived at the kernel level. We were, really concerned about the kernel, and we're very touchy and sensitive about changes to the kernel because we ran into lots of issues over our experience with running the clouds where the kernel could have big impacts in the environment. So we didn't want things messing with the kernel or even running in user space because it could prohibit us also from upgrading. And then the last option that we were seeing out there a lot was people that you would be asked to install an agent on each VM. And while that's a perfectly viable option in many environments, in our OpenStack cloud, we don't have access to our customers' VMs, nor do we control what they install on those VMs. So that wasn't really a great option for us. So ultimately, we didn't like any of these implementations, but we found one that we really liked, and that was actually CloudVisory. And CloudVisory comes with an approach where it's a 100% software solution, and it works with OpenStack Neutron to provide fine-grained network access controls, while also enabling external verification of the network segmentation policies via an audit trail, which is pretty key. So you can actually see the denied workflows. In our implementation model of the solution, CloudVisory actually acts as the security management plane. It then communicates with the Neutron API to learn, modify, and/or verify the security group rules. Neutron continues to act as a control plane, like it should, ultimately controlling Open vSwitch at the data plane layer. So in short, CloudVisory leverages and extends the cloud-native Neutron functionality by extracting away all the complexities of security group rule management, and by auditing and enforcing segmentation policies with strong role-based access control. So it seemed to fit really, really well. And you'll see, I'm going to turn it over to Richard here, and he's going to talk a little bit more about the solution and then give you a demo on it.
Awesome. Thank you very much, Jason. I greatly appreciate that setup and the description of some of the problems around managing security in this very large OpenStack environment where you're losing visibility. How do you ultimately control access in a fast-moving environment with a lot of self-service? And then how do you make sure that it stays compliant? And it really is about the management framework that we supply. So we look at things in the following manner. You have what we refer to as the data or infrastructure plane. You're doing your orchestration, you're deploying your infrastructure, and then we look at the security management plane where we abstract the control so that we have this ability to manage it separate from the infrastructure, and things can be very automated and move very quickly. I'm going to spend just a couple of quick minutes kind of setting this up for you so that you understand what happens when we dive into the demo part of this. So Cloud Advisory is really about the very things that Jason mentioned in his problem set: visibility, control, and compliance. And we start with what we refer to as CV intelligence. This is about a continuous discovery and visualization of the environment. So cloud infrastructure in the provider modality. What I mean by that is whether it's OpenStack or Azure or AWS or Google Compute, it doesn't matter to us. We discover the infrastructure objects and then we actually visualize and map that environment. This includes the infrastructure as it changes in real time, as the policy changes and updates, and we detect and alert these non-compliant policies, the very things that Jason was talking about. How do you know once those policies are deployed that they remain compliant? How do you know that there's nothing malicious going on in the environment, that a piece of malware hasn't gotten into the environment? So we want to be watching and measuring these security policies in real time every step of the way. For us, it is about policy management. It's about automating the policy provisioning. It's about doing granular policy microsegmentation. You heard Jason mention the importance of that because we have businesses spinning up lots of different applications, and we want to make sure that they're getting the right policy control, definitely not too much access. That's a huge problem that is very common. In fact, Gartner spoke about this just in the last week in a paper on cloud workload protection, and they said it is so common for misconfiguration to take place where I've delivered the wrong policy, in which case the application's broken, or I've delivered too much policy, in which case I've opened up the environment to great risk. So we want to be doing real-time policy and flow monitoring for compliance, and we want to be able to do enforcement, meaning automated remediation against any violations. So for us, it's about reducing the human middleware in this, lowering costs, speeding up operations, reducing the speed of change management, right, to speed up operations while we still harden security and ultimately thwart attackers. And I'll cover all of these topics here in the demo, and I'm going to shift to do a share here. Let me get my desktop running, and I will pull you into the Cloud Advisory dashboard to start. So what you will see here is that we are, in this case, monitoring an environment that is a mixed environment. I'm just going to dive right in here and show it to you a different way. This is a security admin view. You can see this is OpenStack, AWS, Azure, even a traditional data center and the internet are part of what we're monitoring and managing here. The key is that we can actually control this from a multi-tenancy aspect, meaning I can push a lot of effort out to lines of business or administrators within lines of business because I can control their access to the environment. So here you see a super administrator that's seeing this entire hybrid environment, but if I log in as a different user, I'll log in as a CC user where they have limited visibility into just AWS and Azure. They're not seeing the OpenStack environment. They're not seeing the data center controls. Or I can even reduce it further. I'll log in as the AF user who I'm going to use for most of the demo here. And in this case, they only see OpenStack. Now, I want to just point out everything we're about to show you works across provider environments: AWS, Azure, Google Compute, VMware. We don't care what it is you're ultimately looking to monitor and manage, but because Jason's focus was on OpenStack, we're going to do all the demo today in OpenStack. So the first thing I'm going to do is just show you a little bit about the visualization here. You notice that I've built out this environment. This is what we discovered. We point Cloud Advisory at OpenStack. We uncover the accounts that are sitting there, and then we map the actual projects. This is how OpenStack divides up their multi-tenancy, if you will, in their environment. So in AWS, we have virtual private clouds. In Azure, we have resource groups. Here in OpenStack, it's projects. And I want to show you how discovery works as the first step of things. So here I've opened up a project. You see there's only one workload or one virtual machine that sits inside of that project. And what I'm going to do is I'm going to go out and orchestrate a couple of additional workloads. You saw an OpenStack. That was the OpenStack interface. I was just proving to you there's only one workload there. And we're going to run an orchestration script here that's going to kick off a couple of other workloads. And what CloudVisory is doing every step of the way is it's visualizing, discovering what's there. So here you see an OpenStack. Those two workloads were provisioned. And when I go back into CloudVisory, you see those two workloads appear as well. So we're constantly and continuously discovering what's going on in the environment, which is very critical for how we ultimately manage the provisioning and policy controls that I'll show you as we go on here. So let me move into the next step of this demo. Now that I've provisioned some additional workloads, I want to show you how I can scope down what I'm actually looking at in the visualization. I'm just going to click a couple of objects here, and then what you'll see is I can click the View Selection button, and what it does, it scopes the environment down. So I'm going to hone in on this next use case, and Jason mentioned this. He talked about this issue of self-service, wanting to be able to push controls out. We know that administrators are going to make mistakes, or DevOps people are going to make mistakes when they deploy policy. What do you do to actually fix that? How do you visualize that when you don't really have any visualization into the environment? This is a demo app that I've got running here, and I'm just going to click this button to access the database beneath it. Oop, it tells me there was a database connection problem. This is exactly the kind of thing that CloudVisory can uncover. I want you to note there's a green line, so we were actually able to load the initial page, so the internet was able to talk to the app layer of this application, but the app layer couldn't talk to the database layer, which is why you see that dashed red line. It tells us there was a communication attempt that could not be completed because there's no policy there to allow it. And this is what we're going to correct. We're going to show you exactly what self-service can look like. So let me open up the actual security groups. What I'm showing you here are actual OpenStack security groups. And you'll see on the right side of the screen there are no outbound rules. There's no rule that allows the app tier to talk to the database tier, and I'm going to correct that with a couple of clicks. I'm just going to go in, click on the red line. I'm going to click over here on the right side, Add Policy. It automatically does all the calculation behind the scenes. I don't need to know anything about OpenStack groups. You see it deploys the TCP 3306 port. And when I go now back to the application, the little demo app, and I try to access the database, let me just refresh the screen here, click the access order, boom, the database is now available. No surprise, you'll see CloudVisory mirrors this, what's going on in production. Boom, now I have a green line because the communication is indeed allowed. And I want to show you what we did in one foul swoop there. Notice now there are outbound rules from the app tier, but there's two things that have to happen, as you're probably familiar with in the cloud. Everything is a white listing environment, right? It doesn't matter, again, whether we're in OpenStack, Azure, AWS. I have to specify the exact egress or outbound rules, and I also have to specify the inbound rules. So simultaneously with those couple of clicks that you saw, we also altered the inbound rules on the database tier, putting in, again, that 3306 port rules that were required there. Okay? So this is the kind of thing that we can very quickly do in terms of assisting with fixing these problems that are going to occur through our deployment process. And again, this is a solution that is meant to be used in dev test just as well as it is meant to be used in production. I'm going to move on to the use case that Jason brought up. Once you provision your security controls, how do you know that everything is good and gold? How do you know they remain compliant? You have to find a way to actually monitor them. And this is something that CloudVisory does, again, 24/7. So I want to pop up the following use case. Again, I want to show you now the application's working. We just saw that, right? I had set the right security controls. I want to show you what can take place when an administrator, whether accidental or maliciously, goes in and actually messes around with the security controls in OpenStack. So this is a situation where we've deployed security groups. We're monitoring and managing the underlying environment now. So what I'm going to do is first show you, again, the security groups that are there. I want you to look at the inbound rules right now. You see the port 80 is there on the left side of your screen. And I'm going to go out to OpenStack. We're reading those from OpenStack. I'll show you that by going into OpenStack right now. You'll see the same set of rules there. So let me just get to the location, dive into the security group, and click Manage the Rules. And here you see the ingress rules. Right here they are, the 3 port 80s. I'm going to delete them. Okay, I'm an administrator. I'm not going to get any warning this is going to impact my application in any way, but you'll see how important these rules are when I go to the application now. I try to refresh the screen, and guess what? It's not going to even get to the web page, right? It's going to time out. Nope, it can't open the page, right? So we have to be watching these things, or you can bring your environment down. And what you'll see here up in the right-hand corner is we've detected an enforcement violation. I'm going to view that and drill into it. And you will see that the enforcement violation comes up and shows you exactly what just happened. It shows you I removed those 3 port 80 rules. Well, that goes against compliance. So you're going to get alerted to this, and then we can either do an automated rollback. For the purposes of the demo I'm going to do, you see rollback there in the left corner. I did a manual rollback just so you'd see it happen. Now when I go back into OpenStack, you're going to see that those rules reappear. There they are. They've come back, and then when I go back to the application is now once again going to be running. So again, just proving out the impact here of how critical it is to not just provision these rules, but then have a way to monitor them for compliance. Let's move on to this idea of workload protection. Again, you heard me mention this earlier, that Gartner spoke about this just this week in a paper where they talked about how critical it is to have cloud workload protection. Why? Because we're finding that the same thing is happening in cloud that's happening in traditional data centers. Malware will get in, it will attack workloads, and then it will do what it does, which is try to take advantage of the east-west threat. It will try to move around workload to workload. So the first thing it's going to do is it's going to compromise a workload, and then it's going to try to spray all ports and find out what ports are available and open. So I'm going to call your attention here to this workload, HRM01, and I'm going to attack this with some malware, so you can see how CloudVisory would detect this kind of scenario. So let me just kick off this simulation script that basically attacks that workload. And when I go back to CloudVisory and refresh the visualization, you'll see, wow, look at that. That malware is doing what malware does. It's spraying the ports to try to find out how it can get out. And when CloudVisory recognizes something like this, we move very quickly to shut this down. So let me show you how we can do that. Again, this can be an automated action. I'm going to demonstrate it manually so you can see it happening. Here you see inside the rules inside this workload show 7 outbound rules. And what I'm going to do is just quarantine this workload with the snap of a finger. And by quarantining it, I'm literally going into OpenStack and shutting down all those rules so there can be no outbound communication. All right? You'll see when I refresh, all those outbound lines go away. There are no outbound communications happening from this workload. Why? Because when I look at the rule set, all those rules are gone. What I've done is I've neutered that malware. It can't do any damage to my environment. It can't jump across to any other workloads. And now what I can do is send my forensics team in, clean that up, find out exactly where that attack came from, and now my environment remains good and gold. The last use case I want to jump to here, and we should be able to wind up with just a few minutes for Q&A in case there is any Q&A. This is really about true policy control and management at very large scale. As Jason said, the environment changes very rapidly at Time Warner. You've got self-service requests happening. I'm spinning up new workloads all the time. I have to have this ability to abstract out security and control and management as my environment rapidly changes. And again, as you heard me say, we do this through this security management plane, which I'm going to demonstrate to you right now. Let me actually go out to the policy screen. This is where we control policies. We can create and set policies that we ultimately provision based on your infrastructure membership or based on, you heard Jason mention tags. When new workloads are orchestrated, they are given certain tags to indicate their context. And based on that context, we will deploy automatically the proper security policy. So I'm going to dig into a policy called PCI, and I want to just point out a couple of things about this screen. In the center, you see that there are inbound and outbound policies. I'll show you those in just a minute. You'll also see here that there are tags that are associated to this policy. You see compliance equals PCI there. And what that means is when we're doing discovery, we're searching for any workloads that have this tag equal to PCI. And what's going to happen here is we're automatically going to provision these inbound and outbound policies. Right now, you see on the right side of the screen, there are no workloads associated to this policy. So this is about this abstraction and this separation of control where I set the policy here, and then ultimately I can deploy it to n number of workloads. So let me actually go run, again, an orchestration script. I want to show you this SAS project has nothing in it. This SAP project has nothing in it. I'm going to go spin up some new workloads, and they're going to have those tags compliance equals PCI. It's just a key value pair. So when I spin up these instances, CloudVisor is going to discover these instances and map them into the visualization, but it's also going to look for any metadata, any tags, and based on those tags, it's going to deploy the proper policy automatically. So again, this is what Jason said, we don't want anything manually happening. So now you'll see as I go into the SAS project, there's 3 workloads. If I click on one of them, you'll see here there is the tag membership, PCI. We discovered that tag, and as a result of that, we automatically deployed these inbound and outbound rule sets, just as were designed in the policy screen. When I go to the SAP set, again, 3 workloads were deployed there. I'll click on one of them. You'll see the PCI tag, and again, the same outbound rules. This is how you deliver consistent policy, and it's also how you manage change at a very high scale. So now what you're seeing is I'm back to the policy screen, and you'll note on the right side, all of a sudden that workload list is being filled out. Now all we did was spin up 3 workloads. Imagine 500 workloads or 1,000 workloads. Imagine workloads across different projects that require different policy sets, and you want to keep this all organized. Well, now I'm going to also show you how the same modality allows you to rapidly deal with change, because I'm going to go into the policy set here, the PCI policy set, and I'm going to change one of the rules. I'm just going to add a rule. I could be adding 10 rules, but I'm just going to add a rule, and you're going to see how adding this rule set, this rule will automatically update. So I'm going to take this TCP port and we'll just call it 636. I just want to show this for example purposes. I'm going to add this rule to this PCI rule set. Again, CloudVisor is going to do all the calculations that are required. It's going to go out to any workloads that are part of this set now, any workloads that have this tag, any new workloads that spin up with this tag, and it's automatically going to deliver the proper policy. So let me just slim down my environment here. I can just pick up exactly the SAP and SAS projects that I showed you before, and I'm just going to open them up, and I'll click on one of the workloads, and sure enough, you will see that we've updated the policy set with that 636 port, right? And that means all 6 of those workloads, imagine 600 workloads, all got those updates, right? So I'm going to stop there. Again, I know that we move very, very quickly in these demos, but it is just due to the fact that we want to get a lot of information to you very quickly. And what I want to try to do here in the last few minutes is to answer any questions that you may have. And I thank you. Some people have typed some questions in, so let me look at the first question here. And this comes from Bonnie, who asks, do you only cover OpenStack in your security solution? No, again, I thank you for asking that question. Everything you've seen here today, CloudVisor works across provider sets. In fact, we can create a policy set like PCI and then deploy it across providers, so AWS, Azure, VMware, OpenStack, et cetera, and so forth, which again is the power of the platform. The next question comes from Dennis. It says, with CloudVisor, what does the operation model look like? Is it application team that will define security group policy for their workloads, or is it centralized security team that will define that? Excellent question. Thank you, Dennis. The beauty of this is it's meant to be used by all of those teams. So some of it comes down to what is the right operational model for your environment. As you heard Jason speak to, he wanted to be able to push as much as he could out to DevOps, but there are certain times where they have regulated policies that they want security to control. We also see teams splitting duties here where DevOps teams only deploy tags and security teams manage policy settings inside of CloudVisor. So you have a lot of flexibility here because of the way we can control the tenancy, in other words, in terms of what you can actually manage and control. And so we can really scope down your ability to only control certain environments, and therefore you might want to push a lot of this out to IT or operations people separate from security, because we have all the management, monitoring, and audit that goes along with it. How do you deal with containers? Great question, Dennis. And what I'm going to ask is that we do a follow-up for you. It's actually very similar. So the modality of the framework works across, again, all these different provider environments, and as well works across containers. But just due to time, I probably won't be able to cover it in just this 2 minutes, but we will follow up with you, and we'll discuss that with you. Is there any agent footprint on the workload? I'm trying to go as fast as I possibly can, and again, appreciate all these questions coming from the field. In the case of OpenStack, it's all about, we are actually deployed at the hypervisor level, so we don't need to go to the workload at all. In AWS and Azure, we can actually use the network flows that AWS captures, so there's multiple deployment options there, and again, this would be something that we would get into in more detail. I think I probably have time for about one last question. If I miss any of your questions, and I can see there's quite a few still in the bank here, we do promise to follow up at a minimum in writing via email, but as well we'd be happy to engage with you post the session to talk this through. This question is for Jason. Did you use the solution to provision and update OpenStack security groups? I think you're still there, Jason. Maybe you can just jump in and answer that.
Yes, I'm still here. So, yeah, well, yes and no. So it depended upon the application and the team and how we wanted that managed, right? So we were letting the DevOps team manage security controls themselves, and then we wanted, in many cases, to set kind of Uber policies above that, where if they did something wrong, it would go and alarm or remediate it. And that was typically how we did things. In our environment, we didn't yet give our end users direct access to the CloudVisor interface to use it to set the security group controls, but that was something that we were looking at doing. We just hadn't got there.
Very good, very good. Yeah, and also to that point, because we have this idea of sort of self-service and secure controls, we have this ability to allow certain teams to take that self-service action, and in other cases, they'll kick the process off, but it will have to be approved and completed by through an automated approval process within CloudVisor, where the security team authorizes those changes. So as much as possible, we do it that way. A quick summary here. Again, CloudVisor is all about a singular interface to manage policies across provider environments, across their native multi-tenant controls of projects, VPCs, and resource groups. We discover and visualize everything as it's changing, the workload context, the data flows, any critical security violations. We automate the provisioning and rapid change management of the environment, and we're doing continuous compliance. We are always checking that flows match allowed security groups, allowed policy, and we're also making sure the policies are never changed against what is the gold compliance state. And this is a solution that's meant to be used across discipline by all different teams. Biz dev, security, and IT. Again, I appreciate the 45 minutes that you gave us. We're right on the end of this session. I do ask for you to click a quick button here. We always like to have feedback from the crowd about how we're doing. Did you find this extremely informative? Did you find it worthy of a follow-up? Was it mildly entertaining, or was it absolutely awful? Richard, you should get a new job. Let us know. We would really appreciate that feedback. And for those of you that punched in questions that we didn't get a chance to answer today, again, I promise a direct follow-up with you from the CloudVisor team. And we thank you so much for your participation. That ends today's session, and we look forward to engaging with you further. Please click a button there and let us know how you felt the meeting went.